Section 7.2.5-T. Determine the area under the standard normal curve that lies to the left of A, where z is equal to 2.59, B, z is equal to 0, C, z is equal to negative 0.02, and D, where z is equal to negative 1.79. In Part A, we want to first draw a standard normal curve with the z-score of 2.59 labeled and shade the area under the curve to the left of 2.59. So the first thing we're going to do is we're going to draw our picture. So now we're going to draw our picture. And so since this is the standard normal curve, we know that the mean is going to be 0. And so what we have is we want to have the z-score of 2.59. And so we want to find the area to the left of that score. So since this is the first step here, we're going to go ahead and then use our table. So let's take a look at 2.59. So we're going to go down here, we're going to look for 2.5. So we have 2.5. We're going to go all the way to 0.09. And then we can see that the area we get is 0.9952. So we can say that the shaded area is about 0.9952. So that represents 0.9952. Okay. So then we're going to come back and we're going to use technology once we finish all of these. Okay, so let's go ahead and then let's move on to Part B. Part B, it says, as before, we want to draw a standard normal curve with z is equal to 0, labeled, and then shade the area under the curve to the left of 0. So again, let's first draw our normal curve. So again, we know that since it's a normal curve, the standard normal curve, we know the mean is going to be 0. And what we're doing is that the z-score is 0. So what we want to do is we want to shade everything to the left and then find the area of that. So let's go ahead and then take a look at our table. And let's find 0 and then 0. Okay, so there is 0 and there is 0. So therefore, that gives us an area of 0.5000. So we can say that the shaded area is about 0.500. So that represents Part 2. Okay, now Part C, it says draw a standard normal curve with z is equal to negative 0.02 labeled, and then shade the area under the curve to the left of negative 0.02. So again, let's draw our bell curve. And again, since it's the standard normal curve, we know that this represents 0. Okay, and then we know that the z-score is to the left of that at negative 0.02. And we want to find the area that's shaded to the left. So let's go ahead and look for that. So we're looking for negative 0.02. So negative 0.02. So here is negative 0.0, and there is 0.02. So the shaded area here is 0.4920. So the shaded area is 0.4920. Okay, part D, it says draw a standard normal curve with z is equal to negative 1.79 labeled and shade the area under the curve to the left of negative 1.79. So again, let's go ahead and draw our bell curve. And again, we know it's the standard normal curve, so we know that this represents 0. We know we have negative 1.79, and we want to shade everything to the left here. So let's take a look for negative 1.79. So we have negative 1.7 and then 9. So we get 0.00367. So the shaded area is 0.0367. Okay, now what we're going to do is we're going to use the TI-84 to find the area to the left. So here is the function on the calculator. It is normal CDF with the lower bound and the upper bound, the mean and the standard deviation. So we're going to draw the curve here real quick so we can see what that means. Okay, so we know that the mean is 0. So we know the mean is 0 because it's the normal curve. We know that the standard deviation is always going to be 1. Okay, and so the lower bound if this is 2.59, we want to find the area from here to here. Okay, this represents the upper bound. And then over here is going to represent the lower bound. And so we can use negative 9999, or we can go a little further with that. Okay, so that's what we're going to do. So we're going to put in our calculator normal CDF with the lower bound to be negative 9999, the upper bound to be 2.59, the mean to be 0, and the standard deviation to be 1. So let's go ahead and see what happens there. So to get to that function, we're going to hit second and then distribution. And this is PDF, which means exactly, but we're looking for CDF, which is cumulative, because we want to add the entire area in between 2.59 and negative 9999. So we're going to hit enter. We get negative 9999 for the lower bound. The upper bound is 2.59. The mean is 0. And the standard deviation is 1. Close the parentheses. And then we should get our area. So let me go ahead and copy that. And so as you can see here, we get the area of 0.9952. Okay, so let's do this again for this part here. Again, we want to find normal CDF. So here we know that we have normal CDF. Okay, so the lower bound here in our graph, let's go ahead and look at that. I'm going to draw this real quick here. So we have 0. So our lower bound is negative 9999. We want to find the area in between here and here. And this is the upper bound. So we have negative 9999. The upper bound is 0. The mean is 0. And the standard deviation is 1. So let's go ahead and do that. Second, normal distribution here. So normal CDF, negative 9999, comma 0, with a mean of 0 and a standard deviation of 1. Close the parentheses, hit enter, and there we get our result that you can see is 0.5000. So that matches our result there. Okay, and the next one, again, we're going to use normal CDF. Okay, so what do you think we can see here? So the normal CDF, we can see that the lower bound here, again, is going to be negative 9999. We can see that the upper bound is negative 0.02. We know the mean is going to be 0 and the standard deviation is 1. So let's go ahead and do that. Second distribution, go down to normal CDF, negative 9999, comma, negative 0.02, the mean of 0, standard deviation of 1. And so we get the area of 0.4920, rounded to 4 decimal places. And then let's take a look at the last one. Again, we have normal CDF. So we can see that when we use normal CDF, the lower bound again is negative 9999. The upper bound is negative 1.79 with a mean of 0 and a standard deviation of 1. So second distribution, normal CDF, negative 9999, comma, negative 1.79 with a mean of 0, standard deviation of 1. We get 0.367. And so there is our results using a TI-34. Okay. So now what we're going to do is we're going to use Statcrunch. So let's use Statcrunch. So in order to access this, we're going to find areas under the standard normal curve. We're going to select Stat, highlight Calculators, and select Normal. And then we're going to enter the mean, the standard deviation, and in the pull-down menu, we're going to decide if we wish to compute where it's less than or whether it's greater than. So in all of our examples, it's all less than. So we're going to go ahead and go to our calculator here. So we're going to go to Stat, go to Calculators, and then go to Normal Distribution. Okay, so for the first example, we know that the mean and the standard deviation is always going to be 0 and 1. Okay, and we know that the z-score is going to be less than, so we have an option of either less than or greater than, so it's less than. And then we're going to put in the number 2.59, and then we're going to select Compute, and then you can see the area with the picture of what we're looking at here. So you can see the area is at the bottom right of this graph. Okay. Kind of make it so you can see. Okay. All right, so therefore there's that graph. Okay, so now let's go ahead and use Statcrunch again for the next one. Again, we're going to use our calculator. So the mean is still 0, the standard deviation is still 1, but now we're looking for that's going to be less than 0. So we're going to hit compute, and then we can see how we quickly get a picture of the graph and the area that we're looking for, which is 0.05. Okay, let's take a look at this one here. Again, we're going to use the Statcrunch. So we already know that the mean is 0, we know the standard deviation is 1, and we're looking for the number that's going to be less than negative 0.02. Select compute, and you can see that we get the same area that we did with our calculator and by hand using the table. So there you can see the area, which is 0.4920. And then the last one, we're going to go ahead and use the calculator here again. So we know the mean again is 0, the standard deviation is 1, and it's less than negative 1.79. Select compute, and if you look at the area, it's 0.0367, which is what we found earlier. And so therefore, there is our result once it loads up. So again, you can see the 3 different ways of being able to get our result.